该是假意没有在那个
我把这个
就是在那个因为太大了，就放在另外一个地方，放在那个就是在讨论区，给你一个名字是当的。你要去这个。
可是他们不是也找得到？
还是再贴给他。
就是像
我是怕他会那个，到时候没给他吗？
贴之前
再给他。
跟你们座位有关的都会考，没有座位没关的大概都不会考啦，也应该就是大概是这样子的，因为跟座位有关的就记不啊，跟座位没关的大概就。
我对点字表示害羞。
像这个大家觉得，这个不会考，这个可能会考，这个。
我们就是等一下。对啊，我们。
这个是跟这个从这个新的底部飞的。
在他那边才会看到。
看到。上。
这里就是 YC 减 Y 嘛，这个好像是。
再记得把一个去，然后就要开成。
这个多一个 F 啊，这个多一个 F 是说多一个。
现在他们那边都看到。
没下来，看清就看清。
设计。那这些项目我就没有详细再讲了，因为这个再讲起来啊，因为我是看你们那个线性代数的 background 学的，所以这些
我对简直保持不熟，反正就清楚。
一直就不会。
我讲下去以后讲得很久，所以我自己讲新的点子，因为这个就不需要什么 magics 的话，这个就要，这个像这个都要的话，这个 space 我就在讲这个 space，
感觉就很扯。
后面这个 body degree，
然后
都要 space， 所以我会
OK 好，那就没什么问题。然后等一下上课，然后这个等一下就可以关掉。
这个。
有兴趣慢慢看是，但是要解释这个清楚的话。所以我刚刚讲说，这些都是假设说你是真的，假设你是保险的，你可能说一直推到这里就是真的是。
对，这个很早
就要这样做，这个要这样做，因为最后就是要给你一些条件，一定要满足这些条件，那么你的 KC、MC 什么东西，就要满足。
要播放这个。
对，它是 positive， 就是 positive， 因为你要证明它 positive。
对，下次。
所以我就
不用操作，因为这个你熟之后也比较好。
对。我还不太熟。
我是熟，可是是刚刚没弄到那个。
刚好印象上。
你没有说那有点什么？
那个后面后面会怎么讲到？那个这个就是变成说比较复杂性，因为过去的经验呢，一般来讲，我讲了一大堆，大部分学生都听懂。这个就是我刚刚讲说，你不需要晓得 system 的答案，我不需要晓得我的 Z 打跟 K 都是，只要我这个 design problem，
所以自己就随便设，
只要它满足这些，你一定是 stable。
所以不管是 pass 跟，
那就是一定要满足这些 pass definite， 就是说你 K 线大一点。
这个就是不管是主动或被动都可以。
主动被动都可以。所以这个控制就是跟那个 system 没关。你只要一个 system， 像我为什么讲这个101这个道理？101那个 mass， 你换一个 mass， 换一个 spring， 换一个 despot， 都是 stable 的。它不会不 stable 的。所以跟101大脑都一点关系都没有。你把101那个 mass 啊，随便换一个。
你说这个控制跟系统没关，所以有控制跟系统。
不是，就是说它的 stability 跟系统没关。它是稳定性跟系统没关。但是你假如要说它的 performance， 那就跟系统有关系。比如讲我那个 DMD， 我的 DMD， 我随便给它的值。Spring 随便装一个 Spring， 随便装一个 Mass， 随便一个 Despot， 它都是稳定的。但是地震来的时候啊，它的那个效果可能不是很好，效果就跟你的系统有关，稳定性跟系统没关。 那一般的控制呢？一般其他的控制呢？它的 design parameter 跟稳定性、跟效果都有关，你不能随便给它一个值，它会不稳定的，它会不稳定的。所以你一般的控制器啊，它是你不小心它会不稳定的哦，它不只说效能不好，它会不稳定。这种控制器它不会不稳定，你怎么写都不会不稳定，但是效果不好。
这是效果。
窗户下这个矩阵会大一点，因为它矩阵可以比较长。
体质大一点，我已经讲过，体质大一点就是 positive definite， 但positive definite 在前面都有讲过，我举例子给你。
就是这样，就是在一个层级。
对，那个都有啊，那个有定义嘛，对不对？前面有定义嘛，前面都有定义过啊。什么叫做 positive definite？ 什么叫做一个体质大一点？
就是你只是给它一个
这个对
转制的跟原来的乘上去会大一点，永远大一点，
永远大一点。
然后那个例如说，就是最下面那句，它的点是变。
对啊，要这样解释。
然后先设7.2才行。然后例如说那个作业好像你没有给他，是不是？
为什么没有给他？
就什么 NC 的作业。
作业在网络上，Web 上第4个
他是说
作业在网络上。
作业的 M-10，我不知道是不是有红木，还是他是红木？我问他一下。
那再来我们把红木叫出来嘛，你把红木叫出来嘛，第4个红木叫出来。
也用这台吗？
对，用这台，你到 Web 上去把那个红木叫出来，再来讨论这些。应该是。
等一下有要讲通用是吗？
对。
要啊。
我
那就是要讲的时候，我再帮你换那个。
好，没关系，我先
上课。
我会把它找出来。
难道是？KC。哦。老师他是说那个他问的那个系统要给。看了一下，好像
那个 MC 要自己去设定啊。我这个 ZLC 我是忘了把那个 determine the value、MC、ZLC 还有那个 KC， 你要自己决定啊。
我就自己设。
对，自己设啊，自己设啊。呀。
不然老师等下再讲一次。
我要讲一次，
好，我也跟他讲一下。
等一下讲一下。那个 MC 要自己设。
25万。
Okay, let us just begin talk about the homework here. Now, the homework here is the 4A. Now, I forgot to put to determine the values of MC. This is, we must have an MC and zeta C and KC.
这样我要调一下，我刚刚不，我以为你要先讲，我以为你要先讲转移。
Okay, so here I say determine the value of zeta C and KC, and I forgot to put MC. You also have to determine MC. The MC, zeta C, and KC are the design parameters. And this is all direct feedback, so it's much easier. There's no dynamics involved in there. So that's it. You need to determine the value, the MC, zeta C, KC. The value may not be unique. So the student A and the student B may have a design parameter, may have design values. They may have a different values of MC, zeta C, and KC, and they will achieve the same 0.05. By the way, here I just say zeta C has to be positive. I didn't tell you that MC has to be positive. I didn't tell you KC must be positive, but that's up to you. You can choose that. But anyway, we'll see what happens. Just give you some exercise. All right, and then I think the second part will be even easier, and that's the value there. You can just check it. I think that's probably answer all your problem now. And now we need to change back to that guy. We change back to this. And how can I change back to this guy here? And lecture now. And we need to change that. Okay.
Yeah.
All right. Just wait a second. I need to let me move back. Yeah. How can I? Okay. So that's to the 6, to the 6. All right. So I'm going to explain. I have a request. I have a request to explain this again. I think most some of the students still don't understand my last questions. The last questions just saying this: the system parameters like a zeta c k c, doesn't matter what kind of system parameters you have. This can be 0, this can be 0, or this can be any value, as long as I choose zeta c and kc, they are positive. The system always be stable. They will never become unstable. That's what it means. In terms of system stability, zeta can be any positive value, k can be any positive value. My design parameter zeta c can be any positive value, can be any any positive value. In other words, zeta c is not function of zeta. Kc is not function of k. Now, in control, we know in control any other method. There's many other methods. There are many other control methods that the zeta c and kc cannot be randomly chosen. In other words, there's many other control methods. Kc and zeta c may be function of zeta and k for the system to be stable. And this is the method that, in terms of system stability, zeta c and kc, as long as they are larger than 0, regardless what kind of value you have for the system, is always be stable. However, the performance may not be good. So this kind of design won't make system unstable. Understand that? There are many other methods, control methods. Even zeta c larger than 0, kc larger than 0, the system may be unstable. Understand that? So if your zeta c and kc, they are larger than 0, this is for the homework. The homework, this is why I give homework 4. The homework 4 just say, hey, although they are stable, but if I like to be my damping to be 0.04, then you have to choose the right zeta c and kc such that your damping is 0.04. Understand now? So if you want it to be specific damping you want to have, then of course you have to choose the right delta C and right Kc, and they are all positive, and also give you the damping you want. If you don't choose that right delta C or K delta C to get that 0.05 damping, fine. They won't give you the 0.05 damping. They might give you 0.0001 damping, very small damping. However, it will never become negative damping. Won't be unstable. Understand now? That's why the homework number 4. The homework number 4 specifically let you design a MC, KC, and delta C such that your damping is the damping you design to be. Okay? The stability doesn't give you the right damping. The stability just tells you that the system is stable. But if you want to have a specific damping, then you have to choose some value, which is larger than 0, but some value to satisfy your requirement. We call performance requirement. Let me tell you, okay, let me just erase that. All right, now the closed loop system is stable that's not right. Stable as long as and Kc are larger than 0. Right? But for a specific performance such as the damping, the closed loop damping, the closed loop system damping is 0.05, that means 5% damping. Then one must carefully select a good set of delta C and K delta C larger than 0 to satisfy the performance. Okay? Although the closed loop system is stable as long as delta C and Kc larger than 0, as it's stable. But for a specific performance. As it performs, this is only stable for the specific performance, such as the closed-loop system damping is 0.0565% damping. Then, one must carefully select a good set of ZC and KC. They are larger than 0. A good set means a good set of values, a good set of ZC and beta C larger than 0. I say values. To satisfy. So then you need to set up a delta C and delta C, the values to that. And these values. Wait a second. How come this is not? Okay. Then this value will depend on system zeta and k. Well, it's more than that. This will depend on system m, zeta and k. Now you understand now? Okay, this is just to explain to you the last sentence I wrote. For system stability, as long as they are larger than 0, doesn't matter what kind of value, I don't care. They are stable. However, if I want to have a specific performance, then that delta C and KC will depend on M delta K. Now understand now? Understand better? No? The homework number 4. If you do homework number 4, then you will feel that to be able to choose delta C and KC, your system M, system delta, and system K, the value are very important now. You have to know your system value. You have to know your system value in order to get a closed-loop system that has damping to be 0.05. If you change your system M zeta K, then your zeta C and KC will be changed to satisfy 0.05. So anytime you change your system, you have to change that to satisfy that. Understand? But doesn't matter what M zeta K, this value. You change it a lot, you can change all kind of value. The system is still stable as long as they are larger than 0. It's nothing to do with the system value, it's the system here. So you have to look at two things. One is stability, one is the performance. The performance, zeta C KC will depend on the system parameters. For stability, they do not depend on delta. Okay? So for any control, you have to make sure first the system is stable. Second, your performance is right. Okay? Understand now? Alright. So So I think you already copied this. Let me write one more sentence. Any successful feedback control requires two conditions. One, closed loop system stability. Two, performance. Well, this is also closed loop performance. So for any successful feedback control, they require one, closed loop system stable. Two, closed loop performance is right. Okay? You must have this condition satisfied. The first condition is your feedback has to make sure the system is stable. After you make sure the system is stable, then you make sure your performance is right. Okay? Now, for ABA, that means what we are talking about, the one mimic TMD. System stability is always satisfied if their C and KC are larger than 0. Regardless the system, regardless the system M, theta, and K. All right, understand now? But the second one, the performance. For example, 5% damping. For example, the 5% damping. Then there are C and KC. Well, a second. Then the second. What's mine?
Yes. Yes.
这个是我的，不管它了。Then delta C K 的 C depend on M delta and K， 懂了没有？听懂没有？这样懂了吗？Understand? So feedback control got two different things you have to do. System stable, performance is satisfied. For AVA, the one we are learning, system stability is not a problem. It has nothing to do with M and delta K, but the delta C and KC depend on M, the system. Now you understand? Understand?
I want to ask, Prof. Why not on? Why we not enough make the system stable?
The system, in AVA, the AVA is doesn't, as long as they are larger than 0, doesn't matter what kind of value you have, the system is always stable. That means the first condition is satisfied. Right? Okay. If you say, okay, I'm satisfied already, as long as the system is stable, I don't care performance, then that's it. If you care your performance, you say, okay, now, but stability is not enough. I want my performance, which is like, say, 5% damping for my closed loop system. Then you need to choose not only larger than 0. You also have to choose some specific value to give you 5% damping. Understand now? And if you need to satisfy 5% damping, then you have to look at your system M, 0 and K. For example, like say 101 TMD. You say, well, I don't worry about the performance. I want it to be stable. Okay, you can put NAM, mass there, MC. You can put NAZC. You can put NAKC. Just put there, and they are stable. They will not make the 101 become unstable. But if you say, okay, now, no, because if earthquake come in, the stability is not enough for me. If earthquake come in, I also like to see the 101 vibrational motions damp out in few seconds. Then you have to carefully choose your ZRC and KC to do that. And that will depend on your 101 structural mass, 101 stiffness. Understand now?
So we have to consider the type.
You have to consider the system M and the system spring. The system, like 101 itself, they have its own frequencies. Then you have to consider the 101 frequencies, the structural frequencies. See? When you build a system, that system frequencies is fixed. Agree? So then your ZRC and the KC has to choose to match that frequency. is not only larger than 0. Larger than 0 is the minimum requirement. That's the minimum requirement for stability. That's the minimum requirement. But if you wanna have your right performance, then that minimum in additional to that minimum requirement, you also have to choose the right value. I say right values. Okay.
How can I calculate the system damping?
Oh, the system damping. That's you can measure it. It's not calculated. You can if you learn the structural, if you take the courses of structures, then they will tell you how to calculate the frequency, system frequencies, and also system dampings. But most likely, the system damping, you don't have a real theory to calculate that. So many cases, we just assume the system damping is less than 1%. That's by experience, right? But the system frequencies, you can calculate that. All right. So that system frequencies, if you can calculate system frequencies, then if you want to have performance 5% damping, then you have to make sure your ZRC and KC give you the right 5% damping for the system. If you think about it, if I don't give the right value, then when 101 is moving around, then that may move long time. They won't damp out. If I choose the right value of ZRC and KC, then they might damp out in 1 or 2 seconds. All right. That's what we call performance. Okay.
他们说他们连不到，
啊，
他们连那边连不到。
这有看到了。
没有，那个是我们这边可以看得到，是说现在这边看一下，什么还在直播？看他们在连，我请他们再多连几次就好了。
哦，在那里。
对，他们
大概是那个 YouTube 那边连到。Okay, I think I need to stop here. It's 8 o'clock now. Unless you have any more questions, you can stay, and then I can stay here to answer your questions. Otherwise, the coupling mathematics, I explain that next week. Okay. So today we only talk about the coupling in the damping and coupling in stiffness. And next time we talk about the coupling in mathematics. Okay. All right, that's the end of our class today. Then, okay, you have any question, you can stay. You're welcome to stay. I can stay here for a few more minutes. Okay, stop. 那你这个会是停吗？
我没有设停止时间，所以我要现在关。
对。
对，
这两个大，
只要带两个带，就一定稳定。
这两个，
对，带就是
这些一定
这些不管，这个怎么使 system 的什么使都没关系，只要它大一点，它就稳定。